Welcome to our today's session on enterprise readiness. This is part of the overall Azure Data Explorer webinar series, and I'm going to be your host today. My name is Henning Rauch, and I'm a program manager for Azure Data Explorer. Welcome. So why should we even talk about this topic? Why should we have a dedicated webinar on it? It's actually quite simple. Customers, big enterprises, they store a lot of data into Azure Data Explorer, huge amounts. And sometimes this kind of big data systems, they require in those enterprises an extra effort to ensure that certain compliance rules will be satisfied. And this is the reason why we are going to have this session today. In this session, we're going to cover topics like identity and access management, encryption at rest in transit, network perimeter security, Azure policies, and business continuity. So let's start. Identity and access management consists of two parts, authentication and authorization. Both are necessary to execute a query or a control command on an Azure Data Explorer cluster, database or table. Authentication is the mechanism of validating the identity of the security principal, and authorization is the process of validating that the security principal which is making the request is actually allowed to make it on the target resource. Let's take a closer look on authentication. There are two different flavors. One is the interactive logon with a user, and the other one is the non-interactive logon with an application. In general, we support only Azure Active Directory based authentication, so no other things like basic authentication or stuff like that. And we support three different types of identities. One is the Azure Active Directory user, like my user, for example. The other one is a security group. And last but not least, the AAD application, also known as, or sometimes referred to as the service principal. And this, by the way, includes managed identities like user or system assigned ones. Now let's talk about authorization. We implemented a role-based authorization model, which means that we have several roles, a couple of them for admins, a couple of them for users, viewers, ingestors. Just take a look at one example. We have a database viewer role here, which can read all data and metadata of a particular database, where on the other side we have another role, it's called a database ingester, which can ingest data into all existing tables in a database, but not query the data. The database user can do both things and additional stuff as well. So having said that, we have a very nice model for role-based authorization, and this is part of the whole identity and access management. Now, what if all of that is not enough any longer? So management on table, database, cluster level, and you need to go deeper with your access model. And you need to go to something that it's called row level security, data masking. This mechanism allows you to specify a function which is executed something like a predicate every time you query a certain table. So you see the example here. This is a function which is checking if the principal which is executing that function or which is querying the table is part of a certain group, in this case the AAD group support representatives. And in case it's that this individual is part of that group, the credit card number will be masked using the using let statement in this case. Then once this function has been defined, the customer table is altered, the policy of the customer table is altered, and then afterwards, if I am part of that security group, queried the table, the respective credit card numbers will be masked, and I will be only able to see the data that I'm allowed to see. Okay, enough talking, let's go into some quick demo. Okay, so what you see here is a Custo as it appears in your subscription, so in Azure Data Explorer. It's called Webinar Custo. And what I would like to show it to you right now is how you can modify the role-based access on the Custo data plane. I'm not going to talk about the control plane, which happens here in the access control, though those are the usual Azure role-based access control mechanisms. I would like to talk now about how to modify the roles of a security principal on the database level. So let's just click on databases and pick one particular database in here. You see here you have a couple of options on the side, query, data ingestion, properties, and also permissions. Let's take a look on permissions. See there's only just one identity defined here, which is this one, and now I would like to add another one. In this case, I would like to add a group which I created up front. So a security group, I'm hitting add. For this kind of group, I would like to provide only viewer access. I'd like to select the principal. I think I call them webinar viewers. Select it and save. It takes a couple of seconds, and what you will see here is that it will appear eventually. You see that it's tagged as a type group. It has the role database viewer, so it's allowed to read from all tables in this database. And if you're part of that security group, you will have access to this data. Now let's check what happens if I'm using the query interface. So I just click here on query. And I already prepared a statement here, so I'm executing a query which is show database sensor data, that's the name of the database principals, where the principal group type is AAD group, and then I'm only interested in the principal and the role, and I get back the principal which I just added. One thing which is also definitely worth mentioning is that Azure Data Explorer is one of the only true multi-tenant services. So this actually means that if you created a database on a cluster or multiple databases on a cluster, you are not limited to the users which are on your tenant. So I could do something like add database sensor data ingesters, for example, and then I could define a set of users. In this case, I'm only interested in a single AAD user equals then ID of the user, so its email address, for example, and then I can specify the tenant ID 1, for example, of that user, so either the tenant ID or the tenant name. And I can also add another one here, which could look like the group equals group ID, and then so this enables the user, or you essentially, to create a true multi-tenant environment. So on a single database you can invite users and groups from other tenants to access Azure Data Explorer. Now that we talked about identity and access management, and I gave you some small example on how to do this using the query interface or the portal directly, let's go to our second main point of the agenda, which is encryption. In this part of the webinar, I would like to cover the encryption related topics when it comes to encryption at rest, not so much focusing on our encryption in transit components. Encryption at rest can be configured on various different levels. So the one thing that you might know or not know is that an Azure Data Explorer consists of some compute and some storage. The compute layer consists of the data management part and the engine part. The engine is connected to the underlying storage accounts, which store the data in shards or extents. And as said, we can enable different levels of encryption. The one most probably, which is the most well-known one, is the one which is using the Azure Key Vault in order to create a transparent data encryption on the underlying storage accounts, which means that you can configure for ADX an Azure Key Vault, which is keeping the key to the underlying storages, and then the storage account, they use this key from this key vault to encrypt the data. On top of that, let's say if we go one layer up, we have the encryption of the disks which are attached to the virtual machines in the engine cluster. As you know, ADX needs to cache some of the extents on the virtual machines which are processing the query to make it like super fast. And those disks that can be encrypted. As of today, this works using a BitLocker encryption, but we'll soon have also a customer managed key option here. And then the one on the lowest level, this is the so-called double encryption. That's another infrastructure encryption offered by storage accounts, and you can just switch it on in ADX. Let's have a quick demo on how that actually works. Let me switch to the browser for that purpose. So you see this is where we left from our last demo. Let's go back to the actual resource group which has been used here. You see here also a second resource right next to the Custo cluster. It's the Azure Key Vault. You can just have a look at it. It has one secret which I configured up front, one key which I configured up front, and I would like to use this one for the encryption of the ADX storage. This key can be either self-generated or also generated with a hardware security module. It's totally up to you. So this has been created up front. Let's take a look at the cluster. You see here on the left a blade which is called Encryption. Encryption with the customer managed key. You just need to turn it on. Then you need to select the key that you're interested in. It's in this subscription. It's this key vault. It's that key, and I always would like to use the current one. I can also specify a version. That's it. Just need to press select and save. And then what's happening now is the ADX cluster will make the handshake from the key vault to the underlying storage accounts, and now your cluster is encrypted with your the data of your cluster is encrypted with your key. Let's continue with our next very exciting topic, which is called network perimeter security. This one is actually key to the strategy of many big enterprises on their way to the cloud. So let's see what we did so far here. We started with our journey and network perimeter security sometime beginning of 2020, where we released a feature which is called virtual network injection. This actually means you can decide during deployment time that your Azure Data Explorer cluster is injected into a VNet. What does it mean? It essentially means that you define a virtual network which is most probably connected to your on-premises resources. You define within that network a subnet. For that subnet, you define a network security group, something like an IP-based firewall. And then you tell the ADX cluster that it should inject into this specific virtual network. What that means is that some of the resources which you deploy into that network are reachable through a private IP address. Let's take a closer look on how that actually looks like. So what you see here is essentially a resource group where I created a couple of resources which are necessary to do exactly what I just said. Let's start with the most important one. This is the virtual network. Let's see which one I picked. And it's this one. In this virtual network, what I'm interested in is the subnet. I have a couple of subnets, maybe one's for clients, another one might be for an event hub, and I have one for ADX, or for Azure Data Explorer. And the very important thing is here to see that I already defined a network security group for it, which is called ADX NSG. If you take a closer look here, you see the private IP address range, the network security group which has been defined for it. And I think let's take a closer look on the network security group before we do any further actions, which is this one. This is very important for you to know. It's also well described in our documentation. So whenever you inject an ADX into a virtual network, you own a lot of, you get a lot of responsibilities on top of that. So you get on one hand side the possibility to control the complete traffic flow, but on the other side you also have the responsibility that we as a product team or as an Azure resource are able to manage and manage our services and make sure that they are running fine. In order to do that, you need to provide us some access here to that virtual network, which is defined in our documentation. So we have some service tags for that, which you can enable. So for example, our management service tag, then we have, this is needed in order to, for example, update the cluster in case that we have a release. Then we have our health endpoints. They differ from region to region. Those are the IP addresses for West Europe. It's nicely defined. Then we have an endpoint for example, a load balancer, in order to make sure and find out if the cluster is actually still running, and a couple of other things. Outbound is also very important. As you know or may not know, an Azure Data Explorer consists of storage and compute. The compute part, which has an IP address and the NIC, so a network interface, needs to be able to talk to the underlying storage. That's why a whitelisting for storage is needed. We need to push some metrics to Azure Monitor and to an event hub. We need to do some kind of authentication with Azure Active Directory, and we need to be able to talk to a certification authority in order to validate certificates. This means before you set up your cluster, you need to define those rules. It's a one-time thing, and then you should be pretty much good to go. Okay, let's just try to create a new Azure Data Explorer cluster and inject it into a virtual network. So we go to New, search for Azure Data Explorer, and here click Create. Just pick a subscription, a resource group, give it a name. Goes to VNet. I'm interested in the region West Europe. Yes, I would like to have the NGV3. I just select a small cluster. The scale is irrelevant for us in this case. Also, this configuration is irrelevant. Security is irrelevant here. And then you can say, yes, I would like to deploy into a virtual network. It's this one. The subnet is ADX. I already have no query IP address available. This is, by the way, needed for our purposes in order to connect to the cluster, in order to manage and maintain it. Let's create a new one. We call it query custom pip. Yes. Check it. Let's create a new one here. DM pip. Okay. Now we need to do some final checks and then you can just create. Now it will take roughly 5 minutes until the deployment is done. In the meantime, we just wait. Time flies and we are done. The cluster has been created. And let's take a look on how it looks like now. Let's go to the resource. What it's actually telling you is, okay, yeah, the cluster is, nothing is set up pretty much, so no database has been created. But for us, the most important point is if you click on See More, you will see that the ADX has been injected into this virtual network and subnet. And what you also see is that those public IP addresses have been used for the query and so for the engine and for the data management part. And what also very important is that 2 new DNS entries have been made. And if you would be now, let's say, if you would be using now a client inside of this virtual network, you would be able to use private-webinar-custo.westeurope.custo.windows.net to resolve the private IP address. And this is essentially what we wanted to have. Okay, let's recap what we just did. And therefore I've chosen to use this kind of drawing here. So we defined, let me just add the pointer here. So we used a virtual network, which is this one, which was called VNet. Inside of that VNet, we used a subnet, which is this one. This subnet is protected by a network security group, and this has 2 responsibilities. On the one hand side, protect the network access. On the other side, provide our cluster management and health monitoring the ability to connect to our service in here in order to make sure that it's running and it's running fine. A couple of resources have been deployed into that virtual network. Let's start with the load balancers. So we have like 4 load balancers here, 2 for the private and 2 for the public part. Those load balancers, they have their backend pools in the virtual machine scale set here for the DM and for the engine. And as you see here, those clients, they will be connecting to the private IP address, to the private load balancer, of the private load balancer, to the DM or to the engine, and the public IP which has been created will be connected or is connected to the public load balancers and enables us to monitor the cluster and make sure that it's running properly. That's it for this part of the VNet injection. Let's take a look on what we're going to do next. So we are looking forward to have pretty soon a new feature which is called subnet delegation. So all of the tedious work that I've shown you before for enabling our access, we will automatize that using a feature which is called subnet delegation. So you will need to delegate that subnet to Azure Data Explorer, and then we take care that all of the health monitoring and management IP addresses have been set correctly, and this will enable you to create a less error-prone deployment. One thing that we're also looking forward in the near future is support for private link. So you will have pretty much a similar experience as you have today with other services like storage, Event Hub, and Cosmos DB. So even from a non-peered virtual network, you will be able to connect to a cluster which is not injected into a VNet. It's very important. And something that will also address some of the feedback that we received in the past is that we will be able to totally separate the traffic that we use for management and health monitoring to your traffic, and this will come sometime later. Our next section is again a very important one, like all of them actually. But this time it enables us to pause for a second and look back. So far we talked about things like identity and access management, so how to authenticate and how to authorize service principals or security principles. We talked about encryption, so how to encrypt at rest, the different levels of encryptions that we support, and we talked about network perimeter security. One thing that's quite cool in Azure is the so-called Azure policies, which lets you apply some automatized governance, so to speak. And ADX supports some built-in Azure policies. Let's talk about them. Let's see which kind of policies we have. So we have built-in policies for encryption at rest with customer managed keys, disk encryption, double encryption, and virtual network injection. And this is how it works. So given that you as a user or your infrastructure as code interacts with ARM, so Azure Resource Manager, the centralized control plane, the policy engine is triggered as well. So you see it's operating based on your input, and then it checks the resources which fall under this policy and sees that some of them are compliant and some of them are not compliant. The list of built-in policies can be found on this website. Just search for Azure built-in policies and then go to Azure Data Explorer, and then you will see all the ones which are available here, like this one for encryption with the customer managed key, disk encryption, double encryption, so all of the encryption levels that we talked about previously are supported here, so you can create either an audit or a deny policy. And last but not least, also the virtual network injection. Let's take a look at an example. Those are parts of the resources which I created for the virtual network and network perimeter security section. But you will notice also here on the side in the resource group, there's a section called policies. Let's click on them. And you will notice that there are a lot of policies enabled here. Let's just search for Explorer. You see the ones which are which have been created here for ADX. So I created two policies, so I assigned two policies to this resource group. One is about virtual network injection, should be enabled. You see both of my resources are compliant, so 2 out of 2. But here we see something, disk encryption should be enabled. And we see that this overall state of this resource group is non-compliant because 1 out of 2 resources has no disk encryption enabled. Let's check. Okay, so we see disk encryption should be enabled on Azure Data Explorer. This is the name of the Azure policy. And you see that webinar Custo VNet is non-compliant. Oh, okay. So let's go there. It's because the disk encryption should be enabled. So let's take a look at the resource. Let's click on security, disk encryption, save it. Now it takes a minute until the cluster is ready again. Awesome! The cluster has been updated and disk encryption is in place, as you can see here. So let's have a look at the policy. We should be now compliant to the disk encryption policy which has been enabled. So let's go back. Let's click on the resource group. Let's check the policies. In the filter, let's add something like this. Oh, excellent, we are compliant. 2 out of 2 resources. Webinar Custo VNet is compliant and Custo VNet is compliant as well because both have the disk encryption enabled. Similar things can be done with the other policies. It's just a matter of what you want. If those kinds of policies are not enough for you, you can always write your custom policies. But we will also add new ones in the next couple of days and weeks. Okay, now we talked about Azure policies and the excellent governance mechanisms that they put in place. Let's talk about the next topic, which is business continuity. The last agenda item of today's webinar talks about the mechanisms to increase the availability of your business in the face of a disruption, such as an outage of an Azure availability zone or a true disaster, like the outage of an entire Azure region. But let's clarify the two terms, region and availability zone, first. A region is a set of data centers deployed within a latency-defined perimeter and connected through a dedicated regional low-latency network. On the other hand, an availability zone is a unique physical location within a region. Each zone is made up of one or more data centers equipped with independent power, cooling, and networking. So you see on the slide on the left-hand side the way to configure availability zones in Azure Data Explorer. It's quite simple. You just need to do that during the deployment phase. So when you deploy into, when you want to deploy into one or multiple zones, you just go to create a new cluster and then pick here in the section availability zones, the zones that you like. So here it's like in the zone 1, 2, or 3. You can decide into which of them you would like to deploy. And then if one of them goes down, let's say in this example, you deployed 6 nodes into regions 1, 2, and 3. We equally distribute the nodes on the region. So 2 in region 1, 2 in region 2, and 2 in region 3. Then if one region goes down for some period of time, your cluster will still be available and you can still work. On the other side, on the right-hand side, this is like a true disaster. It's a true disaster because this would mean that an entire Azure region goes down. So like West Europe is down, all availability zones are down. What to do? We don't have any inbuilt capabilities in Azure Data Explorer to protect against a regional outage scenario. So you have to build it yourself. And we created some nice articles on how to do that, because in the end it's a matter of how much money you would like to invest. But the general guidance that we provide to you if you need to be resilient against a regional outage is ingest into multiple regions. Okay, so for example, as you see here in the picture, create an ADX in region A, might be West Europe, create another one in a region far away from West Europe, Singapore, and the third one, if you need it, in another region like, I don't know, East US. Then you need to make sure that all of those Azure Data Explorers have the same schema, the same security principles, and everything is in place, everything is nicely synchronized. And then you make all of them consume from the same event hub. There are also nice scenarios to make that resilient against regional outage. And then you practically ingest into all of them at the same time. And what happens if one region goes down, for example, like West Europe, you will still be able to query the other regions here. On top of ADX, of course, you need to also, if you'd like to, provide an API for a website, you need to make sure that your business logic knows about multiple Azure Data Explorer instances, and that it can reroute the traffic based on the situation. There are also, of course, this is like a really big scenario if you ingest into all of those clusters at the same time. In our documentation, we provide other options. Some of them incur less money spent. Some of them are, let's say, actually duplicating or tripling the cost. It's all dependent on your needs. We can also have like other options here. Okay. That's it, what I wanted to cover for business continuity. Let's recap. We covered a lot of content in today's webinar and started with identity and access management. So we covered Azure Active Directory integration, role-based authorization. Then we continued with encryption. So we covered things like encryption at rest. We did not go over encryption in transit, but this is something that's given today. We talked about how to bring your own keys. So I showed you how to configure a key vault, create a key, link the key to the Azure Data Explorer, and then all of your underlying data is encrypted with your own key. And we talked a lot about network perimeter security. So the third point from the list, version network support, we covered as well. And then we also covered items like availability zone and what to do in a true disaster, like a regional outage. You also see here a lot of points which we didn't cover. Things like row level security, all of the compliance certifications that we have, also about monitoring. Feel free to leave in the comment section ideas, suggestions, what kind of topics you would like to see covered in one of our next webinars. And it was a lot of fun doing this webinar, so thank you very much. Thank you for staying until the end of the video. Yeah, and have fun with Azure Data Explorer. Thank you. Bye-bye.